In this video, we now want to explore the concept of power. Now, power and work are related in that power is the time derivative of work, all right? So it's the rate at which work is done, all right? Now, you can see from this equation, if work is in joules, time is obviously in seconds, so the units of power are joules per second. And that gets the unit of watts, okay? So power is joules per second or watts, and it's the rate at which work is done, okay? So for example, let's say a 60 kilogram person climbs a flight of stairs that's 10 meters tall, and they do it in 30 seconds. I want to calculate what the power output of this individual is. Now we're going to assume that they climb at a constant rate, and so I can calculate the work done by the person. So if we draw the diagram, right, maybe something like this, the staircase is going to be 10 meters tall. So what is the work done by the individual as they're climbing? What force are they working against? Well, when you lift yourself up, you're working against the force of gravity. So as you climb stairs, that's the force that you're going to be exerting, all right? You're going to have to exert your own gravitational force to lift yourself up the stairs. So if work is force times distance, they're exerting their own weight, mg, over a distance of 10 meters in height. So when you're climbing a flight of stairs, the work you do is equal to mgd. All right, so that's the work. Now in this case, again, we're assuming that the climb is at a constant pace. So there really is no dw dt. This is just w over t in this case, since the rate is constant. So the power is going to be mgd over t, all right? So this is 60 kilograms times 9.8 meters per second squared, times a distance of 10 meters, and that's all going to be divided by 30 seconds, all right? So what does this boil down to? Well, one way you can do it is 60 divided by 30 is 2. 2 times 10 is 20. 2 times 9.8 is 19.6, so 20 times 9.8 is 196. So this person is putting a power of 196 watts. All right, 196 watts. Now, for Americans, okay, one of the more familiar units of power that we use, especially in the automobile industry, is horsepower. Okay, so an automobile is often rated by its horsepower. How strong is the engine in horsepower, so on and so forth. It turns out that 1 horsepower is approximately, I believe it's 746 watts. All right, I'll double check that value, but I believe that that's the conversion ratio. So 1 horsepower is 746 watts. So this individual is roughly maybe 1/5 of a horsepower or so. All right, actually less than that, probably about 1/3, closer to 1/3 of a horsepower. All right. Somewhere between 1/3 and a 4th. So that is actually how you can calculate the power output if the work done is constant. Now, from the original equation that we had, all right, we have that power is equal to dw dt. Now, if let's say I know what my power is as a function of time, and I let my system go for some time interval, and I want to calculate the total amount of work done, okay? So if I multiply both sides by dt, I get that dw is equal to p dt, and now this is an equation that I can integrate. So if I know what my function of power is, I can integrate from the beginning of my time interval to the final time of my time interval, and that will be from 0 to the final amount of work that I've done, all right? And I can integrate this, and this will give me the total amount of work that has been performed over some operation during which the power output may not be constant. Now, one application in the United States, particularly where we measure things in kilowatt hours, that power is very important to us is the use of electricity. And your power company is going to measure things in terms of kilowatt hours, right? But kilowatt hours is actually not a unit of power. If you pay attention to that term, kilowatt hours, that's actually a unit of work, all right? So kilowatts is a measure of power, and the hours is a measure of time. So when I multiply kilowatts and hours, that gives me a unit of work. So if I want to calculate how much I'm going to be spending on my electric bill, all I have to do is note what the average power output of my home is per day, multiply that by the number of days that I have my electricity on, and that gives me the total amount of work that the electricity entering my house has performed, and that's the amount of work that the electric company is going to charge me for. And electricity is usually sold in units of cents per kilowatt hour, a unit of money per kilowatt hour. So however many units of work, however many kilowatt hours of work the electricity entering your home has done, the electric company is going to multiply that amount of work by their rate of unit price per kilowatt hour, and that will be the total amount of money that your electric company charges you. Hope you found that helpful, and next is potential energy.